Just start the lecture in 5 minutes. Binary subtractors and digital system design. So subtractors and adders both have two outputs and two or more inputs. So in adder we have sum and carry, whereas in subtractor we have difference and borrow. So difference is that how much value will be added to the second number so that they will be equal. Okay, and borrow means when we subtract the large number from the smaller number, then in that case we will borrow some value from the other numbers. So that was the adders and subtractors. Next is serial adder and parallel adder. So let's discuss it. So a serial adder is used to add two binary numbers in the serial form. Means one operation is performed, then its output will be supplied to the other address. So the two binary numbers to be added serially are stored in the two shift registers. Means if we have the number of two binary number of 2-bit binary numbers, and that means they will be added serially and their results will be stored in the shift registers. So the circuit adds one pair at a time with the help of one full adder. So one full adder is being used, and the addition will be done on the pair of two on a single time. So the carry output from the full adder is applied to the D flip-flops, the output of which is then used as a carry input for the next pair of significant bits. Means the first pair will be supplied to the D flip-flop. We will discuss what are the flip-flops in the next unit. So right now we just remember that in D flip-flop the same number of input will be supplied, and the carry output of the full address applied to the D flip-flop, and which then be used as input for the next pair of significant bits. However, the sum bit as from the output of the full adder can be transferred to a shift register. So the sums are transferred to the shift registers. So let's see the diagram of it. After completion of this PPT, we will move to the video. We will see that how the shift registers will work. So these are the shift registers. So this is the block diagram of binary serial adder. So first of all, this input is applied to the D flip-flop. So here D flip-flop input is applied as soon as it is the input over here, and one clock is there that will enable this D flip-flop. So one shift control clock and serial input is being supplied to these shift registers. So after processing and moving through this AND gate, the clock is being supplied over here. So then the entry to the D is supplied, as well as the clock carry is given over here, and the output is being considered as input to this full adder. And as soon as x and y are being supplied from A to B, and sum is the using as shifting used as input to the shift registers. This is how the pair of all the data will be processed. So when we see the video, you people will get more idea on this. Okay. Next is the parallel adder. So parallel adder is a combination of digital circuits. See, the sequential adder is a sorry, the serial adder is sequential circuit. Sequential circuit in which we have some memory is being implemented. These shift registers are used as a memory for the serial adder because we have to store the value of sum as well as the carry. But this parallel adder is a combination of digital circuit. Combination means no memory will be required in it, and as soon as the power supply is on, that circuit will work. Otherwise, all the results will be removed from this circuit. So, parallel adder is a combination of digital circuit that adds two binary numbers in parallel form. So, it consists of full adders connected in a cascade. Cascade means with each other, that like in the diagram, with the output carry from each full adder connected to the input carry to the next full adder. So, like this, these are the full adders 0 to n. You can say that n full adders are there, and the pair of inputs like A0, B0, A1, B1, A2, B2, similarly AN to AN will be supplied. And first of all, we have to supply the clock, then the carry of this full adder will act as input to the next full adder. And similarly like this, and our results will become like S0, S1, S2, and S3. Clear? Yes, everyone. Next is the difference between serial and parallel adder. So it will first of all, serial adder will add two binary numbers in a serial form, whereas it is in a parallel form, because number of full adders are being used to add the number binary numbers. So serial adder uses shift register, that is why it is called the sequential circuits. Whereas parallel adder uses registers only with parallel rows. They are not able to store the values in them. So in serial adder, we will use only single full adder. Here we will use the multiple full adders. So carry flip-flop is used in serial adder, whereas ripple carry is used in parallel adder, in which the carry is supplied to the other full adders. So it is a sequential circuit due to the addition of shift resistor, whereas parallel adder is a combinational circuit because no shift resistor is being used. So in this, propagation delay is less, whereas propagation delay is present due to the input carry to the output carry, because one you can say that the carry of one adder will act as input to the other adder. So number of required the full adder is 1, whereas number of required full adder is equal to the number of bits in the binary number. Number of bits are there. Similarly, same number of full adders will be used. So that is why this serial adder will become cheaper as compared to the parallel adder. But yes, we can say that serial adder is slower than the parallel adders. Clear? Okay, so let's move on to the video.
What binary parallel ladder, and we just see what is serial ladder. Suppose we
Sound aa
want
rahi
to
hai?
add our 1011